Okay, good day class. Today we'll be talking about mirror. Yes, mirror and lens. So we'll try to compare and contrast. That's trying to similarities and differences help in making you to be able to remember something very easy. So we're looking at that. Let's see. We have our concave mirror. So let's just look at it this way. We have concave mirror. Concave mirror is similar to my convex lens, which is the same thing as converging lens. And in this case, our focal length is positive focal length. Take note of this. Then we have our convex mirror. Convex mirror is similar to our concave lens, which is the same thing as diverging lens. Here, whenever you hear convex mirror, concave lens or diverging lens, the focal length is negative. Then, when we are doing mirror, we have 5 possible positions. Yes, where the object can be placed. 5 possible positions, and each of these positions have a unique characteristic that the image will be like. You understand? The characteristics of the image at each position is unique and peculiar to that position. So before we do so, let's look at this formula. We know that if we are talking about the pinhole camera, magnification, formula for magnification for a pinhole camera is our image height all over object height is equal to the image distance all over object distance. This is our magnification for a pinhole camera. But the magnification for a mirror, magnification formula for a mirror is your V all over U, which is the same thing as your image height all over object height, or your image distance all over object distance. This is the formula for magnification. Then you know the general mirror formula. The general mirror formula, which is 1 over F is equal to 1 over V plus 1 over U. Then don't also forget that we have what we call the radius of curvature. What's the radius of curvature? Radius of curvature is that distance from the pole to the center of curvature. The pole to the center of curvature gives birth to what we call the radius of curvature. And we know that in mirror, F, 2F is equal to R, such that F is equal to R over 2. So if I'm given the radius of curvature, I can find the focal length. So these formulas are very, very vital when we are solving problems. What is focal length? Focal length is the distance between the pole. Focal length is the distance from the pole to the principal focus. F. So we are saying that F. So we are saying that F or PF is equal to the focal length. Good. Now, Why am I doing this? This class is very essential. Like I said, that we have 5 possible positions where our objects can be placed when we are doing mirror or lens. The essence of this class is to help you to know. You can have an idea of what the answer is before you actually solve the problem. Yes, you can have an idea of what the characteristics of that particular image will look like before you actually solve the problem with the knowledge of what I'm going to give to you. And it's also important to help you to know whether you are right or wrong. If you follow these simple rules we are talking about now, when you are solving a problem, by the time you solve, and the idea you already have in your mind, that's the picture you've already painted about what the image will look like, and the actual answer you arrive at, they will be the same. The moment you are solving your solution, the solution that you have in your notebook and the characteristics that you have in mind is not, then you know that your answer is not correct. How do I know so? Like for instance, we have 5 possible positions of our object. We have beyond C, beyond the center of curvature. Like if I have, this is my mirror. Let's say this is my mirror. This is my pole. This here is my pole, P. Then let's say I measure from here to here. Let's say from here to here as my F. This is my F. So from here to here, is that my focal length? From here to here, it's also the same. If here is 10 cm, from here to here is 10 cm. That's what I was saying, that we have F and we have another F. From here, BC is my radius of curvature. That's my radius of curvature. While from here to here is my F, focal length. Here to here is another F. That is why R, you're having that 2F is equal to R. Then I said that we have 5 possible positions of my object. I have objects beyond C. I have objects at C. I have objects between C and F. I have objects at F. I also have objects between F and P. So these are the 5 possible positions where my object can be placed. Now, if the object is placed beyond C, that is, for instance, like I gave the example here, that this is 10 cm and this is 10 cm. So I don't have to be told when I'm asked to solve this problem that the object is beyond C. If I am given an object and I'm told that the object distance is 25 cm and the focal length is 10, without being told, I already know that that object is beyond C. Why? Because if my focal length is 10 cm, the center of curvature, C, will be 20. Therefore, if that is 25, that means that that object is beyond C. So when I'm done solving, I already know that the characteristic of the object will be what? Because I am told already from my book, even in the drawing, if we were to draw according to the dimensions given to us, because we can draw this. You can see from your textbook that you are told that when an object is at C, or no, object is beyond C, the characteristics is real, inverted, and diminished. When the object is at C, the characteristics of object at C is real, inverted, and the same size. When the object is between C and F, here we have characteristics as real, inverted, and magnified. When we have the object at F, the image form is at infinity. Infinity. Then when we have the object between F and the pole, here the object is magnified, erect, and virtual. Yes. So having said this, let's have a recap of what I said. I said that we have 5 possible positions, and if I'm given the focal length, or I'm given the radius of curvature, or I'm told the characteristics of the image, I already know that's where the image will be formed. Yes, I already know where the image will be formed. So with that, we can see that with this drawing, I can be able to tell what the characteristics of every image will look like in every given problem. Now, let's see. Something I also didn't mention is that the moment you hear the word real image when you are solving problem in mirror, it means that it is positive. Once you hear virtual, or it is formed behind the mirror, that means that that stuff will be minus. Remember, I also said here, if I am talking about a convex mirror, that means that in solving that problem, that I must use the focal length must be what? Negative. If I'm talking about a concave mirror or a convex lens, that means that the focal length will be what? Positive. So the knowledge of all that I have said now, the next class will be how to apply these things in solving what? A real problem, whether JAMB, WAEC, NECO, or GCE. Bye.